Good afternoon, students. Yes, so let us start with the today's class, the last class, physics. Okay, so tomorrow onwards, you people have the CET exams. So yesterday, 19th question we have discussed. So let us continue with the next question. Question number 20, it is from the AC, alternating current chapter. Okay, see the question. A voltage of peak value 283 volt and varying frequency is applied to a series LCR combination in which R is equal to 3 ohm, L is equal to 25 millihenry, and C is equal to 400 microfarad. Then the frequency of the source at which the maximum power is dissipated in the above is. So here they are asking the power dissipation in the LCR circuit. So as you know that in the LCR circuit, how to do the power dissipation. Okay, so for that, the frequency, okay, the frequency they are asking for the maximum power dissipation. Okay, it means that frequency we need to calculate for the LCR circuit. So as you know that the frequency is equal to, it is 1 upon 2 pi root of LC is the formula, which is equal to, okay, here we can substitute the values now. Yes, so what all values they have given, the peak value 283 volt, 283 volt is given, means voltage is given, V naught value. Then next R value is given, then L value is there, C value is there. So all the values are there, just we need to substitute here. Yes, so this is 1 divided by 2 into 10 2 into 3.142 under root of L into C. So L is how much? It is 25 into 10 raised to minus 3, and C is how much? It is 400 microfarad. It is 400 microfarad. So substitute and check what answer you are getting there. Okay, so substitute. If okay, after substitution you should get this answer as 50.3. Do it properly because you will options nodidre 51 ide, 50 ide, 51 point ide. So options are varying in the points. So for that reason, here the calculation should be accurate one, students. Okay, calculation please accurate ag ಮಾಡಿ. It is option D, 50.3. Next question. So the next question is, in the combination of the capacitors shown in the figure, potential difference across the plates of the capacitor A will be. So what they are asking, so here the combination is it is the given, the figure is there, the potential difference across the plates of the capacitor A will be. Okay, so here you can see the capacitor A. So here the capacitor A is there. So in this combination of capacitors shown in the figure, the potential difference across the plates of the capacitor A will be. C option, 1.2 volt. Okay, so if you see from this battery, see whatever the from the battery, if you observe, this is the first capacitor, so this is the second capacitor, and here we have the third capacitor. Yes, if we see all the capacitors, they are in the they are in the parallel combination. Why? Because you can see, so here 1 ampere is there, then next when it is coming here, it is getting split into two parts. Yes, so therefore they are in the parallel combination. So when they are in the parallel combination, the formula is what? Cp is equal to C1 plus C2 plus C3. So that is nothing but 1 plus 2 plus 1. So it is nothing but 2 plus 4, that is 4 microfarad. Okay. Now if you see whatever this 1 microfarad is there, one A iddallen capacitor ಇದೆ, ಅದ್ರದ್ದು value ಎಷ್ಟಿದೆ 1 microfarad ಇದೆ, and that is also in the parallel combination. So therefore, sorry, that is in the series combination. So now here whatever this effective value is there, 1 by CS is equal to 1 divided by 4 plus 1 divided by 1. So if you simplify this, it is 5 divided by 4. Therefore, CS is equal to, it is 4 divided by 5 microfarad. 4 divided by 5 microfarad. Okay, therefore the potential across the capacitor is given by the potential is equal to Q divided by C. Yes. So first Q we need to calculate here, students. So Q1 ಯಾವ ರೀತಿಯಾಗಿ ಮಾಡ್ತೀರಾ? Q is equal to what? It is C into V, which is equal to C. How much you got? It is 4 divided by 5. V, how much you got? V value is nothing but it is 6. Yes. So therefore, if you simplify this, you will get it as that is 4.8 microcoulomb. 4.8 microcoulomb. So therefore, Q value we can substitute it as what? That is 4.8 divided by. Then the C value is 1 microcoulomb. Sorry, 1 microfarad. This is microcoulomb. Micro will get cancelled. So therefore, the final answer is 4.8 volt. This is the voltage. This is the voltage anta navil helbodu. But what they are asking here, in the combination, the potential difference across the plates of the capacitor A will be. So for that reason, what I am doing, V2 is equal to, I am just V minus V1. That is, I am subtracting the values. So V value is how much here, students? V value is the given potential, that is 6. V1, how much you got? It is 4.8. So 6 minus 4.8 is how much? It is 1.2 volt. Option C is the correct answer. C. Yes. C you will get. So to confuse you, they have given 4.8 also, but don't go for the 4.8. Here only for the A capacitor, it is 1.2 volt. Okay, suppose illi the battery irtirlilla andre, that time you could have gone for this 4.8, but their battery is there already of the 6 volt. So therefore option C is the correct answer, students. Going for the next question. So C. The next question is from the ray optics. Yes, see, when a light ray enters a refracting medium, it is found that the magnitude of the angle of refraction is equal to half the angle of reflection. If mu is the refractive index of the medium, then the angle of the incidence is, then the angle of the incidence I value they are asking, students. How you will do? See, first ಏನೇನ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಅದರ ಪ್ರಕಾರ ಬರ್ಕೊಳ್ಳಿ. That is the angle of refraction. The angle of refraction, suppose if I denote it as R dash, is equal to half of the angle of reflection. That is half of the angle of reflection. Or else we can also write it as R dash is equal to R divided by 2. Okay. So we have the refractive index mu is equal to sin I divided by sin R dash, where I is the angle of incidence. So now if I write it, the refractive index is equal to sin R divided by sin of R divided by 2. Why? Because in the reflection phenomena, angle of incidence is equal to angle of reflection. Correct? So therefore, I can take it as sin I and sin R in the replace martini. It is sin R divided by sin R by 2. Okay. So now in the numerator, students, numerator term anna, what I will do anta andre, I'll use half angle formula. That is sin 2 theta is equal to 2 sin theta into cos theta. But here it is only sin theta. So therefore, it will be 2 sin of R by 2 into cos of R by 2. This whole divided by sin of R by 2. So sin of R by 2, sin of R by 2 will get cancelled. So finally what we are getting? We are getting it as what? 2 cos of R divided by 2. We are getting it as 2 cos of R by 2. Or else we can also write it as, that is, mu divided by 2 is equal to cos of R by 2. What we require? We require the angle of incidence. So we just require I value. So then R is equal to Madi, because R is equal to I anta namagu gottide. Okay, students. So if I do it like that, idenagatte. This is here R by 2. It becomes cos inverse of mu by 2. Okay. So this 2, if I take it on that side, it becomes option B, that is 2 cos inverse of mu divided by 2. So I is equal to R, therefore this is the angle of incidency. Yes. So in physics, first you should remember the formula. Second, you should know what question they have given. You need to understand that. Okay. So ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ, conversions are required or what? Conversion ಆದ್ಮೇಲೆ ಕೊಟ್ಟಿರೋದ್ರಲ್ಲಿ ಯಾವ್ದಾವ್ದು ವ್ಯಾಲ್ಯೂಸ್ ಏನು ಯಾವ ರೀತಿಯಾಗಿದೆ ಅಂತ ತಿಳಿಬೇಕು. ಸೊ ಫಸ್ಟ್ ಫಾರ್ಮುಲಾ. Option B is the answer. Yes, go for question number 23, students. Light of frequency 10 to 15 hertz falls on a metal surface of work function 2.5 electron volt. The stopping potential of the photoelectrons in volts is. Here we need to calculate the stopping potential. Okay, work function value is given. The light frequency, incidence frequency is also given. Yes, how we will do the question number 23. Yes. So that is given by, according to Einstein's relation, VES is equal to h nu minus W naught. Yes. So now Vs is equal to h nu divided by E minus W naught divided by E. So this one what we can do now, this is h into nu. So h value is how much? It is 6.6 into 10 raised to minus 34 into frequency is 10 to the power of 15 divided by charge of the electron 1.6 into 10 raised to minus 19 minus work function. It is 2.5 electron volt divided by E, because this E I can cancel here without substitution. Okay, just you need to simplify this C. 6.6 into 10 raised to 34, 10 raised to 15 divided by 10 raised to 19. So here just 6.6 divided by 1.6 ಮಾಡ್ಕೊಳ್ಳಿ. It will be 4.11 minus 2.5 if you do the simplification. So 34 ಅಲ್ಲಿ 15 ಹೋದ್ರೆ, so what is 34 minus 15? This is nothing but no, sorry, 19. So plus 9 minus 19 plus 19, that power will get cancelled. So therefore 6.6 divided by 1.6 is 4.11 minus 2.5. So 4.11 minus 2.5 is how much? It is 1.61 volt. It is 1.61 volt is the stopping potential. Yes, copy down this. We will go for the next question. Okay, students, next question is a radioactive element X with half-life 2-hour decays, giving a stable element Y. After time t, ratio of X and Y atoms is 1:16. Time t is in second. Let's see how to do this. See, that is t is equal to, it is given as 2 hours. Okay, so time is given as 2 hours. Convert it in terms of seconds. Okay, before that what we can do here is, see, according to the radioactive relation, it is n by n naught is equal to, what is the formula here, students? Because what they are saying, radioactive element X with half-life 2 hour, decay is giving a stable element y after a time t. Ratio of x and y atoms are 1 by 16 they are saying. Okay. Ratio of the atoms, how much they are saying? It is 1 divided by 16. So this is equal to 1 by 16 is equal to 1 divided by 2 raised to n. So what will be the value of n? Yes, check. What is the value of n? Yes, it is 8 hour. So n is equal to, we are getting here as 4. As we know, t is equal to n into t half. Therefore, it is 4 into 2. That is nothing but 8 hour. Go for the next question, students. An electric field is given by E is equal to y I cap plus x j cap Newton per coulomb. The work done in moving a 1 coulomb charge from RA is equal to 2 I cap plus 2 j cap meter to RB is equal to 4 I cap plus j cap meter is. Yes, see what equation they have given. The equation E is equal to electric field is equal to y I cap plus x j cap. So if you compare it with RA and RB, if you are comparing with RA and RB, here we have the coordinates as what? 2, 2, and for B we have it is 4, 1. Okay. What we need to do here, students, see the work done in moving a charge of 1 coulomb from RA to RB. The work done they are asking. So work done is equal to formula in Bharata in terms of potential and charge. The work done is equal to, it is Q into difference in the potential, because ಎರಡು points ಅಲ್ಲಿ ನಾವು change ಮಾಡ್ತಾ ಇದೀವಿ, VB minus VA. Correct. So Q is equal to, it is given 1 anta. But what about VB and VA? For that they have given the equation here. ಹೌದಾ? So for that reason ನಾನು ಏನು ಮಾಡ್ತೀನಿ ಅಂದ್ರೆ I'll just differentiate that. So therefore here the differentiation of, sorry, integration of dV between A to B is equal to minus EDR, potential and electric field relation. Yes, so potential and electric field relation, which is equal to, so this is equal to integration of 2 comma 2, and here it is 4 comma 1. This is minus, and here it is y I cap plus x j cap into dx into I cap plus dy into j cap plus dz into k cap. Okay, so therefore this is equal to, so this is equal to, here we have minus integration of, if you simplify this you will get it as y dx plus x dy. So 2 comma 2 ಮತ್ತೆ b point ಏನಿದೆ 4 comma 1. So hope so you will understand this step, students. I don't, because much detail we cannot do as we have very less time. This is x plus y, therefore it is product, and here it is 2 comma 2 and here it is 4 comma 1. So now this is differentiation and integration sign will get cancelled, therefore xy, and the value is 2 comma 2 and here it is 4 comma 1. So what we can do is keep the minus outside. 4 into 1 minus 1 into 4 into 1, and here it is 2 into 2. This is equal to 0. Yes. So potential difference, how much we are getting? The potential difference we are getting it as what? 0. Hagadre answer en barutte. Work done will be what here, students? Work done will be 0. So please copy down. So this integration steps, please go through it later. So but you copy down this first. I'll give you 1 minute. Please copy it. Yes, hope so you have completed this step, students. Go for the next question. That is the amount of work done in pumping a water out of a cubical vessel of height 1 meter is nearly. So very simple question. Here we need to calculate the amount of work done. This is from the work, energy and power chapter. So see, that is the work done is equal to, it is a cubical vessel. So for the cubical vessel, and they have given the height as 1 meter is nearly, okay, it is pumping out the water. So the water density will be 1000. Always you remember the density of water will be 1000 kg meter per meter cube. Yes. Acceleration due to gravity, you can take it as 10. Then next, what they are saying, the amount of work done. So work done is equal to, here force into displacement. Okay, so what we can do here, we can just take it, force is equal to mass into acceleration due to gravity into height h. Okay, displacement you can make it as h, but mass is not given. So mass is not given, so we can write it in terms of density and volume. So it is density into volume into g into h. Yes, so the density you can substitute 1000. Volume, it is a cubical vessel, students. So for the cubical vessel, it will be L cube, right? So you can make it as L cube into rho into G value is given. Yes. So check what answer you are getting here. I have given you the hint. You check the answer for the 29th question. I told you what you need to do. Okay, I'm going for the 30th question, students. Please do the 29th question. Hint is given to you. 30th question. At 27 degrees Celsius temperature, the kinetic energy of an ideal gas is E1. If the temperature is increased to 327 degrees Celsius, then kinetic energy would be. So what they are saying here, at 27 degrees Celsius temperature, the kinetic energy of an ideal gas, is E1. If the temperature is increased to, so temperature is increase ಆಗ್ತಾ ಇದೆ 327 degrees Celsius ಆಗ್ತಾ ಇದೆ, then the kinetic energy would be. So the kinetic energy is given by, it is 3 divided by 2 RT. It is 3 divided by 2 RT. As we can see that the temperature and the kinetic energy is directly proportional to each other, students. Yes. So when you can say that they are directly proportional to each other, ಹಾಗಾದ್ರೆ ನಾವು ಇಲ್ಲಿ ಏನು ಮಾಡಬಹುದು ಅಂತ ಅಂದ್ರೆ, that is at 327 degree Celsius is equal to at 27 degrees Celsius. So this is 327 plus 273 in terms of Kelvin. And here it is 27 plus 273. So this becomes 2 into E into E27. Okay, so therefore this is nothing but what? 2 into E1. That is option D is the correct answer. Option D is the correct answer. Yes. So as they are directly proportional, we can just add, convert that into Kelvin, and we can just add the values. That's it. Yes, completed. Just going for the few more questions. One minute, I'll share that PPT. Yes, next question, students. A body of mass A body of mass 2 kg revolves around a circular path of radius 5 meter. If it makes 10 revolutions per second, its centripetal acceleration is. So the centripetal acceleration is given by students. As you know that the centripetal acceleration is equal to, we have v square divided by r. But our illen kottidare, mass kottidare, radius kottidare, and it makes 10 revolutions per second anta ide. So I'll just take this formula in terms of omega, angular velocity. So therefore it becomes r into omega square. So which is equal to, keep this r as it is. Omega can also be written as what? 2 pi f its whole square. Correct. So therefore if I simplify, r into 4 into pi square into f square. Yes. So therefore this becomes 4 pi square. 4 pi square into this radius. Radius is, it is 5 meter into frequency. So frequency, it is 10 revolutions per second. So that is nothing but 10 into 10. It is 4 pi square, pi. Yes, so if you simplify this, you will get it as 2000 pi square meter per second square. That is option B is the correct answer. C. Yes. So going for question number 32, students, see, a man's near point is 0.5 meter and far point is 3 meter. Power of spectacles lenses required for one reading purposes. Second one, seeing distinct objects respectively. So power they are asking to calculate. So for that, what we are doing, that is the distance. Near distance is 0.5. So here what we can do, that is power is equal to reciprocal of the focal length. So first we need to calculate the focal length, then power calculation will be easy here, students. So for reading purpose, it is 0.5 meter. So therefore it becomes 50 centimeter. I'll convert in centimeters. Okay. So if I simplify this, my P value will be, because you know that 1 by F is equal to 1 by U plus 1 by V. So power is equal to reciprocal of the focal length. So here if I substitute F value and calculate madkoli by using U and V values. So if you simplify here, you will get it as, just a minute. Yes. So power is equal to, you will get it as what? That is plus 2 diopter. It is plus 2 diopter. And for seeing the distinct object, it is given as F is equal to minus 3 meters. So therefore P is equal to enagatte. It will be P is equal to reciprocal of that value. Therefore it is 1 divided by 3 minus 1 by 3. So it is minus 0.33 diopter. Minus 33. That is option C is the correct answer. Option C. Yes, going for the next question. The ground state energy of hydrogen atom is minus 13.6 electron volt. What is the potential energy of the electron in this state? Yes, what is the potential energy? The ground state. Yes, how we will do it, students? So this is nothing but what? You just need to do it as the potential energy is given by what? So they have given that is the kinetic energy. Okay, the potential energy is given by minus 2 into minus 13.6. So what is minus this one? 13.6 into 2, that is 27.2. Option B is the correct answer. So question number 33, option B is the correct answer. Okay. Let's go for the next question. Light of wavelength lambda falls on a metal having work function. So the work function is given as what? It is Hc divided by lambda naught, and the photoelectric effect will take place only if, so photoelectric effect yavag agate when it is lambda is greater than or equal to the lambda naught, lambda is greater than or equal to 2 lambda naught, lambda is less than or equal to lambda naught, lambda is equal to 4 lambda naught. So according to Einstein's photoelectric equation, we have, it is Hc divided by lambda minus Hc divided by lambda naught. Okay. So if you see this one, what we can say, that is Hc divided by lambda must be greater than or equal to Hc by lambda naught. Hagadre, lambda must be less than or equal to what? Lambda naught. So if you see this one, accordingly, option C is the correct answer. Option C. Yes. The next question. 2 point charges are 3 meter apart and their combined charge is 8 microcoulomb. The force of repulsion between them is 0.012 Newton. Charges are. Yes, what they are saying here, that is Q1 is equal to Q microcoulomb and Q2 is equal to, it is 8 minus Q microcoulomb. Why? Because they are saying that 2 point charges are 3 meter apart and their combined charge is 8 microcoulomb. Adradu combined charge ಎಷ್ಟು ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ, they are saying it as 8 microcoulomb. So suppose if you see Q1 is equal to Q, ಹಾಗಾದ್ರೆ Q2 is equal to ಏನಾಗುತ್ತೆ 8 minus Q. Hope so you understood this, because Q1 plus Q2 must be 8. But Q1 is equal to, we are assuming it as Q, and Q2 will be what? 8 minus Q. R is equal to, students, R is equal to, it is given as 3 meter. And F is equal to, it is 0.012 Newton. So therefore, F is equal to, it is Q1 into Q2 divided by 4 pi epsilon naught into R square. So you have the values, you can calculate it. F is equal to, it is 0.012, which is equal to 1 upon 4 pi epsilon naught, 9 into 10 raised to 9. Q1 value is Q. Q2 value is Q into, 8 minus Q divided by R square. It is given in micro, therefore minus 12 agate, erdu charge seri. Divided by R square is 3 square is 9. Yes. Simplified for Q here. Simplify for Q. Yes, students, what you will get? So if you simplify this, yes. So again, madana, that is 0.012, keep it as it is. And here it is 9, 9 will get cancelled, 10 raised to 9, 10 raised to minus 12, 10 raised to minus 3. Yes, 10 raised to minus 3 baratte, and remaining is what? Q into bracket 8 minus Q. Correct? Therefore, so now this is equal to 8 into Q, 8Q minus Q into Q is Q square, and here it is 10 to the power of minus 3. right? So next what you can do, 10 raised to minus 3 ಈ ಕಡೆ ತಗೊಳ್ಳಿ. It will be 10 raised to divided by 10 raised to minus 3. ಮೇಲ್ಗಡೆ ಹೋದ್ರೆ plus 3 multiply simplify it for q is equal to ನಿಮ್ಗೆ equation quadratic equation ಅಲ್ಲಿ ಬರುತ್ತೆ students, because q square is there already, 8q is there. So if you transfer this 10 raised to this one, here it will be 12. ಇದೇನಾಗುತ್ತೆ 12 is equal to 8q minus q square ಆಗುತ್ತೆ. So therefore it will be 8q minus 8q plus q square plus 12, because ಅದನ್ನ ಈ ಕಡೆ ತಗೊಳ್ತಾ ಇದೀವಿ, is equal to 0. So quadratic equation ಅನ್ನು simplify ಮಾಡೋದು ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ. Therefore q is equal to check ಮಾಡಿ, you will get it as 8 or 2. That is option B is the correct answer. Yes, copy down the steps. See, ಯಾವ್ದು ಅರ್ಥ ಆಗ್ಲಿಲ್ಲ ಕೇಳಿ. 2 point charges. So the 2 point charges, ಇದ್ರದ್ದು ಎರಡುದ್ರದ್ದು addition 8 ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ. This one I am taking it as q and this is q2 is equal to 8. Therefore q2 is equal to ಏನಾಗುತ್ತೆ 8 minus q ಅಂತ ಆಗತ್ತೆ. R is given, F is given. We require q. So there is no any other method to simplify this. You have to go through this quadratic equation simplification. See. Let's copy down and complete it. We will go for the next question. So the next question is based on the resistivity formula. A resistance of 2 ohm is to be made from a copper wire. Specific resistance andre rho value kottidare, resistivity value ide. Using a wire of length 50 centimeter, we need to calculate the radius. Yes, see the last 3 questions in that this one we are doing. So we have the resistance is equal to rho into L divided by A. How you can introduce the value of radius here? The radius can be, area is nothing but pi r square, which is equal to r. So therefore pi r square is equal to rho into L divided by r. What we are having here, we require the radius. So this r we require. Therefore r is equal to, it will be what? That is rho into L divided by r into pi. ಇದೆಲ್ಲ ಏನಾಗುತ್ತೆ root ಒಳಗಡೆ ಬರುತ್ತೆ. Okay. Yes. So rho value is given, students. Yes, rho value is given. L value is given, length value from a copper wire. Length value is given 50 centimeter. Make it in terms of meter. R value, resistance value is given. Pi antu ellargu gottidde ide. So you can substitute all the values now under root of 1.7 into 10 raised to minus 8 into L value is 50 into 10 raised to minus 2 divided by what it is R into L, that is 2 into pi 3.142. So if you simplify your R value, how much you are getting? See, your value is 0.0367 millimeter. Option B is the correct answer. Yes, check out. Baratta illa nodi. Yes, go for the question number 37. The input resistance of a CE amplifier. This is based on the semiconductor topic. The input resistance of a CE amplifier is, it is 333 ohm. And the load resistance RL value is 5 kilo ohm. A change of base current by 15 microampere results in the change of collector current by 1 milliampere. The voltage gain in the amplifier is. So very simple question. If you remember the voltage gain formula, the voltage gain is given by, in case of the CE amplifier, it is delta IC current through the collector into the load resistor divided by, that is delta IB current through the base into RI. Okay. So this is equal to 1 into 10 raised to minus 3 milli. Then into RL value is 5 kilo. Therefore, it is 5 into 10 raised to 3 divided by IB value. IB value is 15 into 10 raised to minus 6 into RI value is 333. So simplify, your answer is 1001. Option D is the answer. Yes. Check. D you will get. Yes, question number 38, based on the color code, it is deleted. So for that reason, I am taking another 2 questions. So first I'll solve 41 students. First I am solving 41. See, question number 41. In the output Y, when all the 3 inputs are first high and then low, will respectively be. So first 3 high ide and next 3 low ide. Hagadre output ಏನು ಬರುತ್ತೆ ಅಂತ ಕೇಳಿದರೆ 1,0, 1,1, 0,0, 1,0,1. So first what they are saying, first all are that is high. So high andre idu 1 irutte, idu 1 irutte, idu 1 irutte. So here this is 1 1. So 1 1 iddaga in the AND gate this will be 1, and here already 1 is there, therefore 1 1 output will be what? That is the negation here, therefore it is 0. So therefore the first output is 0 when all the values are high. But with respect to that, we have only 2 options, that is C or D. C ಮತ್ತೆ D ಅಲ್ಲಿ ಯಾವ್ದು ಬರುತ್ತೆ ನೋಡೋಣ. ಹೋಪ್ ಸೊ ನಿಮಗೆ ಗೊತ್ತಾಯ್ತು ಅಂತ ಅನ್ಕೊಳ್ತೀನಿ. ಸೊ ಫಸ್ಟ್ ಎಲ್ಲಾ ABC ವ್ಯಾಲ್ಯೂ ಹೈ ಇದೆ ಅಂದ್ರೆ 1 1 1. ಹಾಗಾದ್ರೆ ಇದು AB1 ಇದ್ದಾಗ ಇದ್ರದ್ದು ಔಟ್ಪುಟ್ ಏನ್ ಬರುತ್ತೆ ಸ್ಟೂಡೆಂಟ್ಸ್? 1 ಬರುತ್ತೆ, ಹೌದಾ? ಸೊ ನೆಕ್ಸ್ಟ್ ಇಲ್ಲಿ ಏನ್ ಗೇಟ್ ಕಾಣಿಸ್ತಾ ಇದೆ, ಇದಕ್ಕೆ ಈಗ 1 1 is the input. What will be the output? The output will be 0. So therefore first output is 0. Understanding? ನೆಕ್ಸ್ಟ್ ಏನ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ, ನೆಕ್ಸ್ಟ್ ದ ವ್ಯಾಲ್ಯೂಸ್ ಆರ್ ಲೋ. ಸೊ ನೆಕ್ಸ್ಟ್ ವ್ಯಾಲ್ಯೂಸ್ ಲೋ ಅಂತ ಅಂದಾಗ 0 0 0 ಆಗತ್ತೆ. ಸೊ 0 0 ಇದ್ದಾಗ ದಿಸ್ ವಿಲ್ ಬಿ 0 and here already 0 0 is there. So 0 0 output will be 1. Therefore option D is the answer. C. Yes, question number 40. Just take the ratios. Simple question. An equiconvex lens of glass of focal length 0.1 meter is cut along a plane perpendicular to principal axis into 2 equal parts. The ratio of the focal length of the new lenses formed is. So the ratio of the lens's focal length, it is cut into 2 equal parts. Therefore 0.2 divided by 0.2, that is 1:1. Option A is the answer. So 0.1 ide, if you are dividing it to 2 parts, it becomes 0.2, 0.2. So therefore 0.2 by 0.2 will be 1:1. Yes, the next question. Which of the following is the shortest wavelength? So which of the following is the shortest wavelength, students? While solving questions, we have done so many questions based on this. X-rays, gamma rays, microwaves, radio waves. Which is having the shortest wavelength? Don't remember? So gamma rays are having the shortest wavelength anta heltivi. Okay, gamma rays are having the shortest wavelength here. Okay, students. Yes. So this completes the paper solving session. So for your practice, we have taken the mock test paper so that you can remember some of the concepts here. So last few minutes are remaining for the exam. So please practice physics alli formulas anna practice ಮಾಡಿ. ಓಕೆ, ಸೊ ಒಂದ್ಸಲಿ ನಿಮ್ಗೆ ಫಾರ್ಮುಲಾಸ್ ನೆನಪು ಬಂತು, ಕ್ವಶನ್ ಯಾವ ರೀತಿಯಾಗಿ ಸಾಲ್ವ್ ಮಾಡ್ಬೇಕಂತ ಅರ್ಥ ಆದ್ರೆ ಯು ಕ್ಯಾನ್ ಕ್ಲಿಯರ್ ದ ಆನ್ಸರ್ಸ್. ಅಂದ್ರೆ ಮೇನ್ ಮತ್ತೊಂದು ಯಾವ ಲೆಸನ್ಸ್ ಅಲ್ಲಿ ಕರೆಕ್ಟ್ ಆಗಿ ನಿಮ್ಗೆ ಫಾರ್ಮುಲಾಸ್ ಗೊತ್ತಿದೆ, ಫಸ್ಟ್ ಆ ಕ್ವಶನ್ಸ್ ಅನ್ನ ಮಾರ್ಕ್ ಮಾಡ್ತಾ ಹೋಗಿ ಅಂಡ್ ಟ್ರೈ ಟು ಅಟೆಂಪ್ಟ್ ದೋಸ್ ಕ್ವಶನ್ಸ್ ಫಸ್ಟ್. ಅಂದ್ರೆ ಜಾಸ್ತಿ ಟೈಮ್ ಕನ್ಸ್ಯೂಮ್ ತಗೊಳ್ಳಲ್ಲ. ಓಕೆ, ಒಂದ್ಸಲಿ ಅದೆಲ್ಲ ಅಕ್ಯುರೇಟ್ ಆಗಿ ಮಾಡಿದ್ವಿ ಅಂತಂದ್ರೆ ದೆನ್ ಯು ಕ್ಯಾನ್ ಫೋಕಸ್ ಫಾರ್ ದ ರಿಮೈನಿಂಗ್ ಕ್ವಶನ್ಸ್. ಸೊ ಎಷ್ಟು ಲೆಸನ್ಸ್ ಫಾರ್ಮುಲಾಸ್ ಪರ್ಫೆಕ್ಟ್ ಇರುತ್ತೆ ಅಷ್ಟು ಲೆಸನ್ಸ್ ಅನ್ನ ಫಸ್ಟ್ ಅಟೆಂಪ್ಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಟ್ರೈ ಮಾಡಿ. Then go for the remaining questions so that you can cover the maximum questions anta helbodu. Yes, so without seeing today 3-4 times, make the list of all the formulas, revise it, and tomorrow go for the exams. Okay, we will meet. Actually we cannot meet because this is the last class. Yes, all the best for your future, all the best for your exams. Yes, thank you all the very best.